All right, morning, guys. In this video, I'm going to go over um, all the answers to the worksheets from the last 2 days that I've given you. Hopefully, this will clear up any questions you guys can have so that hopefully the next time I see you guys in class, we can then continue on learning new material. All right. So for these first three problems, it says find all real and imaginary roots to the equation. All right, now it doesn't say you have to use like synthetic division in order to do it. All right, in fact, we will not have to do it for number two or for number three, right? Because first I would look to see, is there any way I can factor this normally? Well, this is a cube and I can't do grouping. So the only thing I can do is to use the rational root theorem and then see if I can find any zeros using synthetic division. All right, so looking at this, I have the factors of 8, which are 1, 2, 4, and 8, and the factors of 3, which are 1 and 3. So that means my possible zeros are plus or minus. All right, so plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and then plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, and plus or minus 8/3. Okay, now we would then have to go through and start checking all of those. Now, this one in particular does take a little while to find. All right, it is 2/3. All right, 2/3, I believe, is what works. Now, remember, as you're plugging in, since it's x cubed, g and x cubed, 16 of x squared, there is no x, so I have to put a 0 in there. If you don't put that 0, you're going to end up not getting the right answer. So when I bring down that 3, 2/3 of 3 is 2. I add that and get 18. 2/3 of 18 is 12. I add those to get 12. 12 times 2/3 is 8. And there is my 0. Okay. So now I am left with, I know 2/3 works. Now, since this is a cube, I'm left with, this is 3x squared plus 18x plus 12 equals 0. All right. So I'm going to solve this and see if I can factor it. I'm going to take out a 3 and I'm left with x squared plus, what is that, 6x plus 4. All right. I cannot solve that. Can I factor that, I should say. All right. So then you just have to do completing the square. Right. So x squared plus 6x plus blank equals -4 plus blank. So it becomes x plus 3 squared. Get a 9 here. I add a 9, which is 5. So I'm going to take the square root of both sides, which gives me plus or minus the square root of 5. I'm left with x plus 3 equals that. And then I'm just going to bring the 3 over. So my other two answers are -3 plus or minus root 5. And I condensed some of these steps, so hopefully you guys understand completing the square to understand what happened, right? I took the square root of both these sides. I was just left with plus minus root 5, and the x plus 3 just brought over the 3. All right, so my zeros are 2/3, -3 plus or minus root 5. Now, obviously, you have tried all of these other ones probably before you got to 2/3. Like I said, on a quiz, I'm not going to make you have to try it that much, but we're just doing some practice problems. It's good to be able to practice synthetic to make sure you guys are good with it. All right, now for this one, this is a quadratic. You don't have to go through and do all the synthetic stuff. All right, I would just see if you can factor this first. All right, and in fact, it does factor. All right, where you can use 7x and 2x for 14 and 7 and 3 for 21, where this is positive because 7 times 7 is 49. And then 3 times 2 is 6. 49 minus 6 is 43. So that means because that factors that, we set that equal to 0. We get a positive 3/7 and a negative, what was that, 7/2. Those are our zeros for that one. So we have the quadratic. You don't need to do all of this other stuff. All right, now we have a cube again. So this isn't a quadratic. You could do it this way, but hopefully you realize, oh wait, it's 27x cubed and -8. Now, if you did synthetic, it's fine. All right. But what we would find if you do this to cubes, right? If I factor this doing like SOPs, I get 3x minus 2. And then I'm left with SOPs. So you square 3x, which is 9x squared. You take the opposite product, square the second. So you're left with that. All right. If you'd done synthetic, you would have got this 0 2/3. So you set each of these equal to 0. So this one gives me 2/3. I know that's one of my zeros again. So that's 2/3. All right. So now you have to set this equal to 0. And as we learned before, we can't really factor once we use this. So you either have to use completing the square or quadratic formula for this one. I would to make this completing square, dividing by 9 is a lot, right? So that's a lot of fractions. We could use quadratic formula. We haven't done that in a while, so let's do the quadratic formula. So A would be 9, B would be 6, C would be 4. All right, let's do this in a different color here. So we have negative B, so negative 6 plus or minus negative b squared, negative b plus or minus square root of b squared, which in this case is 36, minus 4 times a, which is 9, c, which is 4, all over 2a. All right, so negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is negative 6 plus or minus, all right, let's see here. 4 times 4 is 16. 16 times 9 is 144. So you get 36 minus 144, which is negative 108, I believe, all over 18. All right. So I get negative 6 plus or minus 108. That's going to be an I. We're obviously going to have an I on the outside, but 108 is 12 and 9, isn't it? 9 is 3 and 3. 12 is 4 and 3, which is 2 and 2. So 2 and 3 is 6. So that gives me the 6 root 3 with an I out there. So 6i root 3 over 18. And if I split that up, that reduces to negative 1/3 plus or minus I root 3 over 3. Those are my zeros along with 2/3. All right, so the key is just finding, if you have a cube, right, you find 1 0, and then you have to solve, whether it's by factoring, complete the square, or like we did this one, quadratic formula. All right, so those are the first 3. All right, now for 4, it says factor completely. All right, how many terms do we have? We have 4. The only thing I know how to do is grouping with 4. Grouping doesn't work, right? Grouping doesn't work for this. So what I'll have to do is let's do it synthetically. If you can find zeros, that's how you can factor. It's the same thing. So the only possible zeros I can have are factors of 6 are 1, 2, 3, and 6. Factors of 2 are 1 and 2. So it's 1 over 1, 2 over 1, 3 over 1, 6 over 1, 1/2. 2 over 2, which is 1, we already have 3 halves and 3. All right. So when you go through, and look at this, you would, try 1, try 2, try -1, -2. All right. I believe, just to save time, that -2, once you get to that, it works. Let's say 2, -3, -11, and 6. So I do synthetic, bring down the 2. 2 times -2 is -4. This is -7. -7 times -2 is 14. +3. -6, 0. Perfect. Right? So that works. Which means I then am left with 2x squared minus 7x plus 3. And let's see if I can factor that. So 2x and x. And let's go. If I do 3 and 1, and if I make them both negative, right, I get 2x minus 1 times x minus 3. And then if this is a 0, -2, that means x plus 2 is a factor. So it's 2x minus 1 times x minus 3 times x plus 2. All right, that is it factored completely. If it said find the zeros would be -2, 3, and 1/2, all right, which are all possibilities from the rational root here. All right. All right, now 5 gives you nice, easy directions. Says find this using both synthetic and direct. All right, so synthetic, let's do direct first. All right, direct is where we literally directly plug in -1 right in for every x. For every receiving x, I'm going to put parentheses and I'm going to put the -1. And I would recommend putting the parentheses in there so you don't make any sign mistakes, especially when it's being raised to an exponent. So -1 to the 5th is -1, right? Because it's an odd power, it's still going to be negative. -1 times -2 is a +2. -1 cubed is still going to be a -1. -1 squared is a +1, but there's a negative outside, so it's -1. -4 times -1 is a +4. And then we have a -1. So we have 2 minus 1, which is 1. 1 minus 1, 0. 0 plus 4 is 4. 4 minus 1, I get a 3. All right, now to do synthetic substitution, all right, we put the -1 in the box. We put all the coefficients. Now, notice, -2 to the 5th. This is to the 5th, which means I need to the 4th. Well, there is no 4th. Put a 0. X cubed is 1. X squared is -1. The x is -4 and -1. Yeah, need that 0 in there. So I bring down, I get a -2, +2, 2, -2, -1, +1, 0, 0, -4, 4, 3. And when you do synthetic substitution, the remainder is your answer. So you get the same, you get 3 there and you get 3 there. So that's the answer for that one, 3. But if this was on a quiz, you would need to show both ways. All right, so you know how to do both ways. Okay. All right. Now I know 6 and 7 gave you guys some trouble, right? Only because I think this scared you and this scared you. The fact that we haven't had one where it wasn't just like 5 or 1/2 or 3, but we follow the same steps. All right. So it says use synthetic division. All right. Just see if it's a 0. So I'm going to put -√5 in the box. I'm going to list the coefficients across the top. 1, -3, -5, and 15. For it to be a 0, I need to get a 0 down here. All right, so I just follow the steps. Bring it down, I get a 1. What do I normally do here? I multiply. Well, I can multiply 1 times -√5. It's -√5. All right. Now, what do I do those? I add those. Well, okay, I can't really combine them, but I can do -3 minus √5, right? That's what it means if I add those two together. Now, if I were to multiply, -3 times -√5 is +3√5. All right. And then when I do -√5 times -√5, I just get 5. All right. So I multiply this times that. I distributed the √5. Now I add -5 plus 5 is 0. They cancel out, leave me just with 3√5. Now I multiply 3√5. So 3 times, so on the outside it's just 3. So -3 √5 times √5 is 5. 5 times 3 gives me a -15. And I get 0, which means yes, it is a 0. All right, it is a 0. If you're following the same steps, you just have to go with the radical on the outside. And I think that's what was a little confusing. Same thing here, -2 plus I. All right, so we got a complex number here. So we got 1, 6, 13, and 10. All right, so I'm going to go through and bring it down. So that's 1. So I distribute that. Obviously, it's just -2 plus I. I combine them. 6 and -2 is 4. So I now have a 4 plus I. All right, I do 4 plus I. So I got to multiply this out, which means I can move this 10. It's going to get a little. All right. When I multiply here, just to distinguish the thing, I'm going to use a different color. So 4 times -2 is -8. I'm then going to have -2 times I, which is -2i. 4 times I is 4i. We combine -2i and 4i. We get +2i. And then I get I times I, which is I squared. All right, but remember, I squared is -1. So I really have a -9 here. So -9 and 13 is, was that once again a 4? They get 4 plus 2i. All right. All right. I know the screen looks different. Sorry, I had to pause to do something else for a second, and I moved off the screen and came back, and it was, oh my god. So remember, we brought down the one times -2 plus I is this. So we left off where we had 4 plus 2i, I believe. All right, so I multiply that out. 4 times -2 is -6. -2 times 2i is -4i. 4 times I is 4i. They cancel out, leave me with I. Whoops, 4 times -2 is -8, by the way, not -6. I'm an idiot. I added those. And then I times 2i is 2i squared. But 2i squared is really -2. -8 and -2 is -10. 10 and -10, you get 0. All right, so by doing, you're still doing the same things. We're just dealing with imaginaries here. Our goal is still to get 0 here. Since we got 0, then yes, it is a 0 of the function. All right. So only thing you guys had left on this one was, let's see, skip that. We don't learn that stuff yet. Number 10, listing all the possible rational zeros. So we look at our constants. We have 12. We look at our leading coefficient, which is 4. So I get 1, 2, 3, 4, 6, and 12. 1, 2, and 4. Then to write all the possibilities. Now, these are all plus or minus. I'm not going to write a plus or minus in front of all of them. So it's plus or minus 1, 2, 3, 4, 6, 12. Now I put all these over 2. So it's 1/2. 2 over 2 is 1. I already have it. 3 halves. 4 halves is 2. I already have it. 6 halves is 3. I already have it. 12 halves is 6. Don't need to write it. Then I put everything over 4. 1/4. 2/4 is 1/2. I already have it. Don't have a 3/4. 4/4 is 1. Already have it. 6 over 4 is 3 halves. Already have it. 12 over 4 is 3. And there's my answer. Remember, these are all plus or minus. Plus or minus 1, 2, 3, 4, 6, 12, 1/2, 3 halves, 1/4, 3/4. Those are all the possible rational zeros. It just says to list them, doesn't say to find them. All right. And then the last one is 13, determining if it's a factor, it's a factor of the second, if it is factor completely. All right. So this is where we take our -1 and we do our synthetic. So I have 2, -5, 3, 6, -4. All right. 2, -2, -7, 7, 10, -10, -4, multiply, get 4, get 0. All right. So this is a this is a this is a 0. All right. So -1 is a 0 of it is a factor of it. All right. So x plus 1 is a factor, and this leaves me with 2x cubed minus 7x. What is that? Plus 7x squared plus 10x minus 4 equals 0. All right. All right. Now, what you can do from there, all right. So this cannot be factored using grouping. All right. You could check to see if any other whole possible like rationals go in. They do not. All right. So it is completely factored doing x plus 1, 2x cubed minus 7x squared plus 10x minus 4. And there you go. And there is your answers. All right. So that's the first worksheet. All right. This was the second one. Okay. Now, for all of these, all right, for all of these, you should have just first list all the possible rational zeros. All right. Pull the rational zeros. And, so you're looking at the constant. So in this case, it's 1. All right. So I have 1 and I have 4. The list all the factors 1 of us have 1, 1, 2, 4. So your only possible rational zeros are plus or minus 1, plus or minus 1/2, and plus or minus, I'm sorry, my mouse is going on here, plus or minus 1/4. All right, so I always would start with 1, -1. All right, so I'm going to start with 1. I think I get lucky here because it's 4, 0 for x squared, -3, -1, let's say. 4, 4, 4, 4. And that's 1 times 1 is 1. And there we go. We got 0. all right, which is 4x squared plus 4x plus 1. That's what leaves me with. Once you get down to a squared, you don't have to do synthetic anymore. You just see if you can factor it. If you can't factor it, then you do complete the square or the quadratic formula. This does factor. It's 2x plus 1 squared, which means my other 0 is negative 1/2. So negative 1/2 and 1 are my zeros. All right, this one has like a double root. The word we use is multiplicity. We'll talk about that coming up soon. All right, so 0 is there for 1 and negative 1/2. All right, now 2 is the only one on here that is to the fourth. So we're going to have some interesting, this one just is treated a little bit different than all the other ones. So our constant is 9, which is 1, 3, and 9. Then we have 2, which is 1 and 2. So the whole numbers it could be potentially are plus or minus 1, plus or minus 3, plus or minus 9, then 1/2, 3/2, 9/2. All right, like I said, I would always start with 1, and then I normally go with negative 1. 1 does not work, I believe. So save time, I'm not going to throw all the ones that don't work. I believe negative 1 works. Now you might have found 1 if you went 1, 2, 3 first. I think also 3 works. So I get 2, 1. It doesn't matter which one you find first because you'll eventually get all the same answers. All right. 2 times, let's see, negative 2, negative 1, 1, negative 18, 18, positive 9, negative 9, 0. Okay. Now, what's left here? All right. I have 2x squared minus, cubed minus x minus 18x plus 9. All right. So for this one, all right, the only thing we can do is potentially factor this. That's the next squared. Sorry. All right. So if I were to take out, all right, if I were to take out an x squared, I'd be left with 2x minus 1. If I took out a negative 9, I'm left with 2x minus 1. I can do this by grouping, which means this is x squared minus 9 times 2x minus 1. X squared minus 9 factors to x minus 3, x plus 3. So my zeros, I have negative 1. This gives me positive 1/2. And these give me plus or minus 3. So here's a case where we were able to factor by grouping. Now, if you did not realize that you were factoring by grouping, you can do synthetic division with just those answers. All right. So for example, you would then have to guess around a little bit. And I would have, eventually maybe you would have tried 3. And then you've been left with 2, 6, 5, 15, negative 3, negative 9. You see it works. So then 3 works. And then you're left with 2x squared plus 5x minus 3, which then factors. And that would have given you your 1/2 and your negative 3. So there you would still get the same answers, even if you didn't realize that you could factor by grouping. Now, we just got lucky. This does not always happen where we get lucky when we're left with a cube. So the only thing you can do to factor when you have a cube is to group. If grouping works, great, like it did here, awesome. If it doesn't, you then have to do synthetic division with what was left here. Don't do it with the original. Do it with what you got left after you found the first 0. And you'll find at least one more rational 0. And then from there, you get down to a quadratic and you'll be able to find the other 2. All right. So now the rest of them are all cubes, which means once you find 1 0, you'll be able to solve the other 2 rather easily using a quadratic. All right. So for this one, I have 6 and 1. So it's either plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. All right. So, if you did 1, it didn't work. Maybe you go to 2, maybe you go to negative 1. All right. This one, let's go to 2. I think negative 1 does work, but like I said, doesn't make a difference what order. You should have some reason for doing it the way you do it though. 2, 4, 8, 3, 6, 0. So I'm left with x squared, plus 4x plus 3. It does factor nice and easily. X plus 3, x plus 1. So my zeros, negative 3, negative 1, positive 2. Don't forget about the one you actually found up here. That's actually a common mistake. If you just leave it up here, you have to list it in the answer. All right. For this one, leading coefficients 1 again, so it's just all the whole numbers possibilities of 20. So 1, 2, 4, 5, 10, and 20. All right. And for this one, like I said, always would start off with 1, 1, 8, 11, negative 20. 1 times 1 is 1. That's 9. 9 times 1 is 9. That's 20. That's 20. And I get 0. So this is x squared plus 9x plus 20, which is x plus 4 times x plus 5. All right, so that means negative 4 is a 0, negative 5 is a 0, and 1 is a 0. All right. And like I said, on a quiz or test, I'm not going to make you look for long to find your zeros. All right. I think the ones on this one are relatively symbolic of ones that would give you on a quiz. I don't think I gave you any ones you would have to try too much here. All right. So this one, you got to try all the factors of 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. All right. So I end up with, I think, let's try 3 first. 1, 0. That's because the only reason I'm trying 3 first is because I know the other ones don't work. All right. I'd normally be starting with 1. All right. So everyone knows that. Always start with 1. All right. 3, 9, negative 2, negative 6, 0. Okay. So this is x squared plus 3x minus 2. Now, this does not factor. You might be like, oh, 2 and 1. Yeah, but it's a negative here. All right. If that was a plus, great. So you would have to do completing the square for this one. So x squared plus 3x plus blank. Or you can use the quadratic formula. Move the negative 2 over. All right. Half of 3 is 3 halves. Square that. We get 9/4. All right. 2 is 8/4. 8 plus 9 is what? 17/4. We then will take the square root of both sides, and we end up with negative 3 halves plus or minus the square root of 17/4, which is 17 halves. That plus 3 are my zeros. All right. Then the last one, we have 3 and 6. So it's plus or minus 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. But then it's also all of those numbers also over 3 are the possibilities. All right. So as we go, I would probably do, I normally do 1, negative 1, 2, negative 2, 3, negative, like I go in that order. All right. So I believe negative 2 ends up working. But once again, negative 2, that's not too many that you would have to actually try before you get it. So negative 6, negative 10, 20, 3, negative 6, 0. So it leaves me with 3x squared minus 10x plus 3 equals 0. 3x, x, I believe that is a 1, that is a 3. These are both negative. 3 times 3 is 9. Negative 1 gives you negative 10. So it's positive 1/3, positive 3, negative 2. There are your zeros. All right, so hopefully after, seeing me do these problems, now you can go back if there's something you didn't understand, go back and see if you can understand a second time me going through. All right, and then I'll give you a couple more other problems to practice a few today. And then hopefully, if there's still any questions when I see you next time in class, I'll clear them up, and then we can start with some new material. All right, hope you guys are doing well, and I'll talk to you soon.